Hi. I was playing with flip-flops and realized that I needed an inverter. I didn't want to spend $5 on shipping and wait 8 to 10 business years for some lame online order. I didn't want to go to Radio Shack either and spend $5 on a hex inverter. Just one simple component for fiddling around. So I came up with this. And here's how it works. A simple inverter with a very common NPN transistor. Here's the symbol. And here's the diagram. So right off the bat, we want to look at this transistor here, the base of which is essentially the input. So 1 or 0, high or low. Ground is basically the output. But let's start by covering up the input. That is to interpret it as having no input. If that's the case, then we just have the power flowing through the resistor, the diode, and out through ground. So the diode lights up because it has no reason not to. You might be looking at this number here, the resistance, and that's because I was thinking of a 470 ohm resistor. I was fresh out, so I just put two 220 resistors in series for a margin of error of 6. And for such a simple circuit like this, it doesn't really make a difference. But anyway, so this is the case when you don't really have any input into the base of the transistor. So in other words, you have a 0 here for an output of 1 because the LED is lit up nicely. However, the moment you put a signal current through this resistor and into the base of the transistor, now you can have current flowing from the collector through the emitter, and this part of the circuit is in parallel with the diode. And what that does is reduce the potential across the diode to below its forward voltage, which for a blue LED I think is 3.6 volts. Correct me if I'm wrong, but anyway, the diode definitely goes off, and that represents an output of 0, or a low output. So again, input of 1, or high input, into here, it's inverted to a low output. So that is what an inverter does, in this particular implementation at any rate. So with that in mind, let's move back to the circuit itself. And as we can see here, a white for signal goes through the 2 resistors into the base and right to output. So input of 1, output of 0. And as you might expect, we unclip this, an input of 0 through this pin, and an output of 1 because it's powered through here. So there you have it, a quick and dirty inverter, the simplest of logic gates implemented on perf board. Oh, I should add that contrary to what the diagram might suggest, for low voltage like this, and not to mention a simple implementation like this, it's perfectly fine to use the signal input in parallel with the power, as we see here. I mean, it's generally a separate power source, but here we're sinking such low current back into the Arduino that it's not really straining it to do it this way. But anyway, that's all I have for now.